Good morning, everyone. I'm Yun Shen, GovInsider's Deputy Editor, and welcome to the Innovation for Sustainability panel on day 2 of the Festival of Innovation. There's a renewed sense of urgency when we consider the future of our planet, and even amidst a public health crisis, it's absolutely clear that we need to build back better. But climate change can sometimes be a little bit overwhelming to talk about, and today we want to explore some of the simple steps that we can begin taking to prepare the world for the future. Our panelists will be bringing their expertise from different aspects and areas all across the sustainability conversation, whether that's energy, data centers, or material science and research. Please join me in welcoming Xiao Xiong Hua, who is the CEO of SP Digital, an energy tech firm that's part of SP Group, the leading energy utility in Asia Pacific. Next up, we have Tan Tin Wee, who is the Chief Executive of the National Supercomputing Centre in Singapore. Tin Wee is one of Singapore's pioneers of internet research, and he's also the only Singaporean to have been inducted into the inaugural Internet Hall of Fame. And last but not least, we have Loh Sian Jun, who is the Executive Director of the Institute of Materials Research and Engineering at A*STAR. He's also Executive Director of the Urban and Green Technology Horizontal Technology Program Office, and he has been dubbed the Materials Man, and he's a front runner in Singapore's scientific research. Thank you, gentlemen, for joining me this morning. Now, let's start off our conversation talking a bit about where we are right now. And Xiao Xiong, I'm going to bring my first question to you. How has the pandemic highlighted the need for green and sustainable innovation?
Actually, the need for green has been and sustainability has been there for a while. But I think the pandemic really brings out a lot of these things because a lot of the attention on the pandemic has to do with it's very existential. How long as humans will we last on this earth, and therefore I think a lot of attention has been brought back to climate change and things that are affecting our environment as well. So I do think that that's something that's driving a lot of attention to this. But at the same time, the pandemic with a lot of the things that are happening also drives the things that for example, food supply, and for example, how would the impact of the things that we use during the pandemic, like for example the face mask and the hand sanitizers and things like that. So some of these things really bring to attention, what is the impact of these things that we're doing now for the future generations. And of course, finally, I do believe, at least in the initial part of the pandemic, when a lot of countries went on lockdown, the use of energy, the generation of energy actually reduced tremendously. The number of cars on the road, the number of industries that are generating pollutants and so on has reduced, and that has created the view of clear skies. And there's a very stark difference from what it was before the pandemic started, before all the lockdowns appeared, and that created a vision, or rather the perception of what it could be, if we were a lot greener. And that triggered the thinking of people and so on. And I do think that is one of the drivers of what it is today. But obviously, as time goes by, we fall back to our old habits, and things have escalated considerably. But I do think that it is actually very apt for us to start doing a lot more things about this at this point in time.
Definitely. Yeah, I think I was seeing online that in some places of the world, animals were coming back, the skies were clearing up. I think that really sets that vision for us, that this is possible and this is something that we can work towards. Sian Jun, I'm going to come to you for this question as well. So how do you think the pandemic has highlighted the need for sustainable innovation, adding on to what Xiao Xiong has shared?
Yeah, I think that, the way from the materials angle, right, we have seen that the pandemic has changed our lives. We are packing food more often these days, and we are actually generating a lot of plastic waste. Things like face masks, disposable face masks, they are being disposed of at tons per day globally. And I think that this is sort of a worrying problem when we think about the amount of waste that we are generating. the pandemic, right, will eventually be over, I hope. But it is important to note that, the plastic waste, they are just not going to disappear tomorrow. And that really, highlights the need for us to look into new sustainable technologies that we can use to replace such materials. You may also recall that perhaps when the pandemic first hit in China, and they went through a lockdown, they actually had clearer skies. They had blue skies, the animals are coming back. I think even in Singapore, the otters were coming back during the lockdown. And this just goes to show, right, how fast nature can react, if us humans were not really part of this ecosystem. It's really a sobering thought. The world actually is a nicer place without us polluting it. So I think this pandemic, to me personally, has taught me that it's very important to ensure that the things that we do not damage the environment, and we got to coexist peacefully.
100%. And I think I'm going to come back to you on the whole idea of plastics, because I think this is something that it's been a conversation that's difficult to talk about simply because of the necessity of everything when it comes to healthcare. But I believe you have a couple of projects or tricks up your sleeve that you can share with us later on. But I'll come back to that. For now, I want to turn to Tin Wee to talk about supercomputing. So I think supercomputing, it powers so much of the world that we know today, especially as we are so digitalized. So it's helping medicine, it's helping data analytics, smart government, but it also consumes a lot of energy. So how can we begin to make supercomputing more sustainable?
Yeah, so you're quite absolutely right that supercomputers are guzzlers of energy. But you should place it in the perspective of supercomputers as the bellwether of the forerunner of what is to come. Today's mobile device was a supercomputer 20 years ago, right? So the supercomputer that we run can consume up to 1 megawatt of power just for one supercomputer. So it's this foreshadow of what is to come, that eventually, as we shift from the real world into a digital world, I imagine all of us will probably never go back to where we were reporting to work every day, 9 to 5. Digitalization has shifted more than 50% of the population to realize that they don't need to go to the office at all, and perfectly perform just as well online. And this means that all the data that is being generated, even as we speak right now, is stored in a database somewhere. And every bit and every byte you store, every bit you transmit and every byte you store is actually consuming energy. And you multiply by the gigabytes, or now they say it's a yottabytes of data that is being shot around. Maybe the old adage of do not print this email, save a few trees. The adage should be changed. And offices for the reduction of email and their attachments, their huge attachments, should be created so that we will pay attention to the amount of data we generate and the amount of data we refuse to delete away, and keep on spinning this. They're spinning 24/7 all the time and using energy all the time. So we have to pay attention to that. So the problems that we bring to bear on the solutions that bring to bear to this problem is exacerbated within the supercomputing environment, and our efforts to build a more efficient data center, to reduce the number of watts that we sustain per byte per compute, is something which will impact the world, maybe of not immediately now, but of tomorrow, as we shift to a greater globalization, digitalization, transformation.
Definitely. And while I'm staying on supercomputers for just a little bit, can you share a bit about how is the National Supercomputing Center leading the whole movement around sustainable ICT, at least in Singapore?
Yeah, so for example, I told you 1 megawatt of electricity. So what do you do to cut down the electricity cost? Use more efficient chips. So when we move to our new supercomputer, we're using more efficient energy, less energy consuming chips. The other thing is that we make our data center more efficient. For every watt of electricity that we use to power the computation, to drive your websites, to run the calculations in a supercomputer, typically in a commercial data center, you need another 1 more watt of electricity to cool the system. So we all know that semiconductors power our desktops, right? And all the way to supercomputers. And they are semiconductors and not called semiconductors for no good reason, because they are poor conductors of electricity. And every time electricity runs in, it generates heat, which we get rid of. So for every 1 watt, you pay another watt of electricity to cool it down. That's very wasteful. So this is what we call PUE of 2. We have managed to bring our data center operations down to 1.08. So for every 1 watt of electricity, we're using 0.8 watts to cool it down.
Right.
By a few mechanisms of which probably too boring for all of us here, but we make use of many techniques to do so. We even have a digital twin or model of our supercomputer, which we model what ifs in our supercomputer, a supercomputer model inside our supercomputer to model the simulate the airflow and so on.
Wow, fantastic. So what I'm hearing from you is use more efficient chips, making sure that the data centers don't use as much energy, and send fewer emails. So, okay, I think shifting gear, still on the topic of energy, but now more for the everyday user rather than for larger businesses. So, Xiong, how is SP Digital prioritizing sustainability in utilities?
Actually, this is a huge topic on its own, right? Because SP Group as a whole, as in the utility, we are moving towards this direction. Sustainability is a key tenet of what we want to actually achieve in time to come. Right? And I think that's not unique to SP. That's not unique to just what we're doing here. It's actually all utilities are going towards this direction, because there is a general realization that the generation of power does contribute a lot to really the pollutants that are in the air and creating a lot of unnecessary issues and stuff like that. So we are generally moving towards this direction, and within that space alone, we would range from the engagement with the consumers, driving things like energy efficiency, driving things like more effective use of energy, and basically providing information for consumers to make decisions on their energy use, like smart meters where we deploy to the residents, and then creating the app to show people how they're consuming the energy, creating programs, and we have this Green Up program where we try to nudge our users towards a more sustainable lifestyle through many different means. I think not just energy alone, but in terms of consumption of plastics, reduction of consumables, and so on and so forth. So we have this entire program that's really focused on our app to drive this, but that's really on a consumer level, right? But then the spectrum is beyond that. Then we move on to things like commercial buildings, industrial buildings. How do we actually achieve energy efficiency? Again, the techniques and the modus operandi is very much the same way. We are trying to now move people from over-consuming energy to the more sensible way of using energy, using different technologies to reduce the energy consumption. And I could talk a lot more about the things that we're doing. Like, for example, we are providing utilities monitoring and insights to our end users, different commercial buildings, and so on, by putting meters, smart meters, all over the building, the facility, the properties, and not just monitoring like the consumption in order to bill, right? So it's also monitoring like the consumption for different large equipments, different points where there's actually use of electricity or water and so on and so forth, right? In order to collect this data and provide a sensible dashboard for the facility managers to be able to monitor and make changes and tweaks and so on and so forth. And then, of course, we go all the way to the grid levels, right? So what I talked about earlier on is really commercial and industrial. And on a grid level, we are trying to do more with energy storage systems, solar panels and so on to be able to manage the and also be able to monitor all the this what we call the distributed energy resources in island-wide approach. Right? So I would say from SP Group perspective, and SP Digital is basically the organization that's managing this from both our external customers and also internal stakeholders. We are trying to do this from end to end, like from the residential consumers all the way down to the grid level. So that's the spectrum that we are trying to cover.
Fantastic.
I want to buy green electrons from you, Shao Xiong.
You can.
Right.
So from our app today, you can use a feature called My Green Credits, which is basically buying renewable energy certificates. And if you buy from our local Singapore providers, then basically you're buying green energy that's generated within Singapore. But of course, RECs is not just a Singapore thing, right? It's a global thing. So you can actually buy RECs from Thailand, you can buy RECs from Vietnam and so on. You are contributing to the movement, and you are actually buying green energy because that's a globally acknowledged thing that, this RECs really do represent green energy.
So for my data center, supercomputing data center, can I get a discount from you to buy solar energy? Yeah?
We can talk after the...
It's also a business deal now. Yeah, but I think it's fantastic. So we have, all the way starting from the data centers. And then after that, we have, the residents and the citizens. We have the industrial estates and the buildings. We also have right down to the grids. And then we've also seen, how all that can power and feed back into the data centers as well, especially when we power that with renewable energy. And then that's going to reduce, that has the potential to reduce carbon footprints a lot more. So after this, we can continue with the business deal between the two of you. But for now, I'm going to turn to Xian Jun. So you already talked a bit about, this whole issue of plastics and then how we need to find, possibly alternatives to that. Can you share a bit about, more broadly also, how materials engineering will be helpful in the fight against climate change?
Right. I think it's an understatement to say that materials engineering is very important, right, to fight against climate change. And I think if we take ourselves one step back, looking at what is the issue we're trying to address and all this climate change, it's actually global warming. The amount of not only carbon dioxide, but maybe methane that's going up in the air, we're really trying to reduce that. And what produces all this carbon dioxide? And from the materials point of view, one of the big polluters will be the incineration of, let's say, plastic waste. And when the plastic gets burned up, you leave no trace, right? You get CO2 plus H2O. And in the early days, I think that was a very convenient way, to get rid of things. You don't have to throw them in the landfills. Our Pulau Semakau is already getting filled up. We got no space in Singapore also. But this is a global problem. And in terms of materials engineering, we have to think about how are we going to keep the materials in the loop, so to speak. So this means that we are going more in terms of not only just recycling, but a broader term known as circular materials. This is to keep the entire cycle of materials within the loop without compromising on the physical properties of the material. And this actually involves a lot of intricate chemistry, a lot of materials engineering, and a good dose of understanding of materials physics as well. And what we have been looking at over at A*STAR are very innovative ways of building up plastics using non-traditional materials. So these materials feel like plastic, but actually they have inbuilt chemistry that allow them to disintegrate, and you can rebuild them again and again and again, and it can take place over multiple cycles. The other way that we are also looking at this is also to look at perhaps things like food waste, right? Singaporeans love to drink coffee, and you can get a lot of coffee waste generated in just a matter of days or weeks. The question is, what can we do to this coffee waste? We can either burn it, which will produce more CO2, or we can take it and produce something good with that. And over at our place, A-Star, we have actually taken coffee waste and we have turned it into plastics using our innovative process to try to develop useful materials, materials that can last, materials that can stay with us without being burnt. And we try our best to make sure that, you know, these materials are actually non-toxic as well. So that, you know, people, you know, as they see and they touch, you know, they have no problems with it. So these are just some of the snapshot of the things that we are doing, trying to change the way we see materials, but that involves a heavy dose of materials engineering as well.
100%. And I think what you said about turning coffee waste into plastics is quite interesting. I think it's something that I would never have thought of. Interestingly, I came across an example. I think NUS was trying to turn coffee into alcohol, actually. Obviously, not as useful as plastics, arguably, but definitely something that's interesting to consider. Okay, I think for now, Sasha, I want to turn to you on the topic of electric vehicles. I know this is something that I think has picked up pace a little bit in the region over the past year or couple of years. So what do you think is the potential of electric vehicles in helping countries reduce carbon emissions?
I mean, there's two sides of the coin, right? And this actually is a highly debated point as well. So from one end, people do say, look, as vehicles grow, then if we centralize all the generation of electricity at a location, and then you just use electricity. In reality, is the vehicles themselves do not produce like pollutants immediately during it, right? So that's one part of it. Which I think it's beneficial and it's great and so on. But on the other hand, the centralization of generation of electricity, which is what most of our systems are running today, like Singapore is based 95% on gas-fired power plants. Then you're really just moving the equation from the cars to the power plants.
Right.
But obviously the power plants are a lot more efficient, right? Because they centralize the thing. But on the flip side of it, then efficiency is driven down because you still need to transmit the electricity across the grid and then finally to reach the chargers and so on. So there's always this flip-flop of pros and cons of whether EVs are really useful or not. And of course, the batteries themselves within the cars, they are not exactly the most sustainable thing, right? Because they will last 10 years, 15 years maybe at max, and then you got to change them. And the materials within the batteries, there are issues with it. And what do you do with the batteries? Like, how do you recycle the batteries? There are actually a lot of efforts to recycle the batteries, to convert them into energy storage systems, and allow them to have a second life. But even that, after a while, they will still need to be. I mean, you need to think about a third life for them, because after a while, the efficiency of those batteries are going to be reduced and so on and so forth. So it is a race, right? So you got to see what's the next few things that are happening. For me, I always think about the story about the horse carriage and the cars. So obviously at that point in time, when people were doing horse carriages and there were horses and in the streets and so on, there's a lot of waste material coming out from the horses, and they definitely pollute the cities and they become a lot dirtier. It becomes a lot unhygienic and so on. And in reality, it was a big problem. So the introduction of automobiles, of cars into the cities helped a lot with that, because then you don't have literally, you don't mind me saying this in forum, you don't have horse shit on the streets anymore. So that was really helpful, right? But over time, then the replacement of horse carriages with cars, that introduced a different problem, which was the problem that we face today, internal combustion generating a lot more waste in terms of pollutants to the air and so forth. Now we are talking about electric vehicles. So 50 years down the road, 100 years down the road, what kind of problems are we going to face with electric vehicles? Actually, we don't know. But do we have a better alternative from what we have today? I would say, at a point in time when horse carriages changing to automobiles, actually it was a good change. So for us now, at least I personally believe that the change from internal combustion vehicles to electric vehicles is actually a good thing, but we mustn't think of it as from an extreme, right? Because it is not this is the panacea for all the ills of pollution, right? Because it is not. It is a one step further down the road, and I think we do need to think about a few steps further down the road, like what are we going to do with some of these other issues that we'll be facing potentially.
Yeah, I think that's definitely an important point that you brought out. I mean, with every new tech, there will be different things that we need to think about. And I think you also mentioned something that related to what Xian Jun shared earlier about how, the circular economy of materials, or in that case, the circular economy of batteries. I think with this idea of introducing EVs, it might be something that we are not as familiar with, but definitely something that we want to move towards. What are some things that we can begin thinking about or considering then? So what are some things that maybe, authorities, regulators, or maybe even, private people, private businesses who are working on these electric vehicles, what are some things that they need to keep in mind?
Yeah, so it's actually a big paradigm change. It doesn't seem that way because, from a car that generates pollutants and make a lot of noise to a car that doesn't generate pollutants and doesn't make a lot of noise, is for the end user is like that's not a lot of difference, but obviously the marketing about it's a lot greener and so on. So that's partially true. But the reality is it's the ecosystem changes altogether, because the way that we actually refuel the car, as in previously you do pump petrol into the car. Now you use electricity. The infrastructure completely changes, right? So what are petrol stations going to do? Like what are the Caltex, Esso, the SPCs of the world, the Shells of the world? What are they going to do, right? So that's a paradigm change on that. And the car itself, the vehicle itself, the components within the vehicle have changed completely, because a lot of it are based on the ICE engines, the internal combustion engines, and this completely changes, because right now basically an electric vehicle is a battery on wheels. Like literally, that's what it is. It's a battery. You have nice, comfortable seats on it, and then it has 4 wheels, and that's about it. Right. So you look at if you do radio control cars, that's exactly the EV that we are talking about. There's not a lot of change in that. And if you compare your RC cars with your actual ICE cars today, you see that there are a lot of differences, right? There are thousands and components within and each of these components that are powering this internal combustion engine cars, they are manufactured by different companies, and there's a whole ecosystem of shipping and logistics and stuff like that. The repairing of the vehicles and so on and so forth. Imagine all these companies are all wiped out tomorrow because of electric vehicles. Then you can see how momentous the change is for the ecosystem, and all the industries are involved in it. And correspondingly, then all of these industries have an impact on the environment, right? Because of the way they conduct the business, the way they and so on and so forth. In a way, it is better, because with the reduction in number of components, basically the manufacturing and all those things that are involved are greatly reduced. And because they're greatly reduced, then the potential generation of pollutants are reduced and so on and so forth. But the reality is we don't know yet, because there's a lot of projection of what is going to happen. There are a lot of things like what I'm saying now, right? Because all these things that people can see, but it has not happened yet, because sometimes we don't really know how this is going to happen. Just like to repeat my analogy earlier, it's just like when we switched from horse carriages to cars, we didn't really know what the repercussions down the road, right? The same way as we are changing from ICE cars to EVs, we don't really know what's the repercussion further down the road. But that's human history, right? So very often we just charge ahead and do what we think is the correct thing, and we just try to adapt. Yeah. So
precisely, what you just said has a new twist to it today with artificial intelligence, especially. Everything that you mentioned can actually be modeled in a computer somewhere, and predictions can become even more accurate. Whereas from horse carriages to ICE, you may not really be able to predict what's going to happen. But today you can do a complete materials analysis. Am I not right, Xian Jun? Complete analysis of the energy flow. even as we shift from the internal combustion engine, the energy requirements, to the power generation, you can actually model the whole thing. And the more complex it is, you can have supercomputers that can model these different moving parts and run scenarios, right? What if I do this? What if I do that? And it's a tremendous tool for policymakers to try out their policies before they implement it.
Absolutely.
Yeah.
Yeah.
And
But I think that
rigor has to be in decision-making process, which we are not seeing at the moment. So we are trying to encourage policymakers, especially decision makers in CEOs level, C-suite people, to really pay attention to this possibility of creating digital twins and running that simulation.
Yeah, this is absolutely right. I totally agree with this. In fact, I mean, just to sort of sidetrack a little bit, since you were asking about EVs, this has nothing to do with EVs. Within SP, we are actually building digital twins as well of the networks that we're managing, right? Our electricity network, our assets, and also our gas networks. We are taking a lot of this data in. We're building a digital twin, not of components, not of individual items, but we are trying to build it a digital twin of the network itself, right? So if, let's say, part of the network, certain things happen, how would that impact different parts of the network? That kind of modeling is what we're trying to do. And also, like bringing all the data, we are able to do a lot of anomaly detection and be able to predict what are things going to happen if certain things happen along the way, and so on and so forth. So very true what you're saying, Timmy. I think very apt in this current world.
Yeah, I think, Timmy, I'm glad that you brought it up, because I think digital twins have been used for, I think, quite physical things in a sense, building new buildings. Obviously, SP has been exploring that as well. And I think quite incidentally, when we talk about EVs, we have exactly the right number or the right type of people on the panel here who could be, helping us prepare a lot more for the whole new world of EVs that are coming up with digital twins and modeling. So thanks very much for bringing that up. But for now, I think we'd like to talk a bit about some of the green innovations from around the region. So we've talked a bit about the work that we are doing, but from what you've seen around the world, what are some things that have caught your eye when it comes to sustainability innovations? Timmy, maybe we can start with you.
Yeah, some of the innovations comes with generating of energy, because ultimately, if you trace the loop, connect the dots, when I say shift the models to digital twin, you're generating more data, you're generating more compute, and then let's shift the loads to the data centers, and then our data centers consume more electricity, to the point that even in Singapore, even though more than 50% of data centers are in Southeast Asia are based in Singapore, you can see government has issued a moratorium of creating new data centers, because we're deeply concerned about this shift, right, to the digital environment, creating repercussions which we may not be able to control so quickly. Let's put a moratorium and see how we could tweak it a little bit better. So we in NSCC, for example, realized this quite an early stage, and we are now actively looking at ways in which we can consume, not to decarbonize, so to speak, right? To reduce the amount of carbon footprint based on our electricity usage as we shift, as the world starts to shift towards the digital environment. Right? So yesterday I was on a call from a teleconference with colleagues and on a seminar and at the APNIC conference. And one of the Indonesian colleagues are saying that they're using more hydroelectric power. Now that's as green as you can get, right? Then I asked them about geothermal, because they sit on the Pacific Rim of Fire. Can they make use of heat, natural heat from the volcanoes or the earthquake zones, and to power, generate electricity? And this is what the Nordic countries are already doing, right? Geothermal energy. So how about wind? It may be quite windy in some places in our region. We can use these novel sources of energy to power our ever-growing energy requirements.
Fantastic.
Materials need to shift as well, right? As we shift to these new energy sources, right? And some are even talking about nuclear, right? In this region. And some people are obviously, the green environmentalists are trying to avoid that possibility, right?
Yeah.
And it comes back to materials, which Sian Jun is the expert here.
Yes, and I was going to bring the next question to Sian Jun as well. So, Sian Jun, what are some innovations then from around the region that you think you're really excited and hopeful about?
My main thing that I've been scanning throughout the world is hydrogen these days. Hydrogen is undoubtedly, I think, going to be the next gen fuel that we are talking about. But we are now facing a challenge where we are thinking about hydrogen. There are many different types of hydrogen, the multicolored hydrogen, as I always like to call it in my group discussions. The green hydrogens, which is actually generated from fully renewable sources. The blue hydrogen, which is actually generated hydrogen, but you capture the carbon that is generated from that. So typically, you get liquefied natural gas, and then you pull out the hydrogens and you extract the carbon from that, and you have to extract it in a very efficient manner. And the other way is the usual gray hydrogen, which is actually not really preferred at all. And I think that there has been a lot of debate that if we want to go into green hydrogen, the amount of renewables that we have in the world is not able to produce enough energy to generate that green hydrogen. And also, there are many other challenges with hydrogen. How are you going to transport it, right? One of the things about hydrogen, if you want to pump it over as a liquid, you can't bring it over as gas. The volume is just too big. You will have to liquefy it, and it's really cold. The temperature. It's minus 250 over minus 250 degrees. And this is super cold, colder than the temperature that's used to ship your Pfizer vaccines, That's a lot of energy that's going to be used. And of course, that means that you have to find alternatives. And one of the key alternatives that has sprung up is Japan, right? They are like me, they are also getting a little bit excited about hydrogen. And they're trying to ship hydrogen in a liquefied manner at room temperature. And they do this using a very clever method. They harness this molecule called cyclomethylhexane. This is actually a roundish looking molecule which is fully saturated. Fully saturated meaning that you have filled up all the hydrogen that you can possibly fill in the molecule. And they are shipping it from places like Australia over to Tokyo Bay. They're shipping it from Brunei over. And what they do is then they extract the hydrogen from it. And having extracted that, this cyclomethylhexane turns into toluene, which they can ship back over to wherever the source is. So that is something exciting. But I have been thinking about the energy involved in doing all that shipping and how does it compensate for that. The other thing which I also saw a very interesting, and this was actually a couple of years ago, was Australia thinking about piping green electricity over to Singapore. This is a very ambitious effort. Billions of dollars will be involved, and they're thinking about having a long electrical cable pipeline underneath all the ocean, and I don't know the fault lines, how they're going to even do that, right? This is a key challenge, but it brings to mind an idea how countries can start to sell their green energy. Australia obviously has lots of sunshine. Singapore has been declared as a renewably disadvantaged country. We just have too much cloud cover to get very good sustainable green energy. And so those kind of developments are exciting us. And also closer to home, I think one of the interesting projects that we are looking into at the moment is how are we going to recycle things like solar cells. And this is very important because we now have solar cells all over the place. And once the lifetime runs out, or if it doesn't work too well anymore, where are we going to throw that? And so one of the projects that we're working on looks at how we harness all these things to turn them into heat harvesting materials. So actually these solar cells are very useful for that. And as Tim Wee was talking about, all the data centers and all those things, they produce a lot of heat, but these are actually waste heat. So if we can actually take this futuristic material, put them in those data centers, can actually take out a little bit of the energy that we can use up some other place. So just some of the thoughts that has been going on at the scientific world and all the discussions that we have been participating in.
No, Tianjin, you're absolutely right, because that's what we are already planning to do. It's what they call industrial symbiosis. The waste material of one industry becomes the raw materials of the next industry. And if we can chain that up, they will eventually become that circular economy which we spoke about, where the output of one step in the chain of events of that circular economy or the circular material manufacturing process now becomes the output of one step, becomes the input of the next and the next and the next. And I'm a biologist, by the way, so the all living things have already mastered that ability of creating that circular chain of events that makes it sustainable, right? So with the sunlight driving that cycle, and we find ways of optimizing every step and chaining these steps together and finding the correct materials, which is right up your field, right? Finding the correct material that can capture the energy and the molecules from one step to the other. So here's my pitch for people studying material science and chemistry, right? But one point that you mentioned about drawing energy from another geographical location, we're thinking about doing the opposite as well. That means my supercomputer is based in Singapore, but as you say, we are severely disadvantaged. Can I take my computational requirements and send it somewhere else for calculation? Somewhere where it's greener, electrons are easily available, where maybe a free cooling can take place. So we are negotiating with Finland, for example, to see whether we can make use of their data center in Finland, where they need a lot of heat, right? In Finland. And then we send their computational jobs to them, and then they do the calculations and send back the answers back to us. That works for me. And that's why, as you can tell, I've been involved in building the internet over the last 3 decades. And we have built the network infrastructure to be able to support that concept. And we've tested it out in the last 5 years in A*STAR, how we can transmit data at even faster speeds than what the current internet allows for. We make use of a different protocol called InfiniBand. And ACRC in A*STAR, we've built an InfiniBand ring around the world that allows us to distribute supercomputing jobs to different computers all over the world.
Wow.
The original internet was created because supercomputing centers in the US had to communicate with each other. They couldn't build all the compute in one location. They had to distribute it, and these supercomputers had to talk to each other, and the users had to come and connect to that supercomputer without having to transport themselves to the supercomputing center. You can see how that transformation is happening both ways, right? Can we draw energy from another greener source, or can we send the jobs to another remote locations that is more energy efficient?
Absolutely.
And still get the same results.
Yes, I love that we're finding so many opportunities for collaborations, not just between, countries, but even, within the panelists themselves. We are heading into the final minute of our session today. So let's maybe end off with a quick fire round. Climate change can often be quite a gloomy topic, so let's end off on a bit of a positive note. So if you could summarize, this in a tweet, maybe 280, 140 characters, what are you hopeful about in the area of sustainability? Maybe, Sao Xiong, we can start with you.
Oh, giving me the tough ones. I'm not really good at trying to summarize it, but I think if for the immediate one, I think it's really very apt. I think it's really about information, because if we want people to change, then we need people to be informed. So they need to know before they can change. So I think information, insight, that's what I would be talking about. I can't formulate in 140 words, but that would take some time. But so information and insight about themselves and how they consume it. That's what I would say.
100%. And Xian Jun, what about you? How would you summarize what you're hopeful about?
I would say we will get there. We'll get there one day, because this is not an unusual occurrence, right? I think CO2 levels in the history of Earth, right? I mean, it has been high before. In fact, during that time, the there was hardly any ice on Earth. I think that was like 10 or 15 million years ago. Our Earth is very resilient. We can actually get back there. The only trouble is that we are actually increasing our carbon dioxide levels way faster than what it was in the past. And we have just got to find the ways. And I think humans are really resilient. And that's why I say we will get there.
Definitely, definitely. And Tin Wee, finally, let's end off with you. What are you hopeful about?
I named our first petascale supercomputer Aspire, Advanced Supercomputing for Petascale Innovations, Research and Enterprise. I hope all the young people especially will aspire to doing the noble endeavors that will make the world a much greener, sustainable, and better place for everyone to live in.
Amazing. I think that's a wonderful note to end us off on. Thank you to all our panelists for sharing your insights with us today. And a huge thank you to everyone in the audience for joining us. We've heard from our amazing panel on the steps that can be taken to mitigate the impact of climate change moving forward. We hope that you've learned something new and that you are hopeful and excited about our future together ahead. Right after this, I'll be having a conversation with Chong Mien Ling, who is the Chief Sustainability Officer at Singapore's water agency, PUB. We'll be continuing the discussion on innovations for climate change, but this time we're focusing on water. Do look forward to a splashingly fun conversation. But that's all for this session. Thank you so much. Until the next time, goodbye.